My packing company needs to construct a rectangular storage box with an open top and a square base with a volume of 300 meters cubed.
Okay, materials for the base cost $12 per meter squared, and materials for the sides cost $7 per meter squared. I need to find a function to model the cost of the box in terms of the length of the base, b, for a box with an open top and a square base. First, I have a diagram of the box with b as the length of the base and h as the length of the height. I begin with the knowledge that the volume of the box is 300 meters cubed, and I also know that b squared times h gives me the volume. I set these two equal to each other and solve for h, giving me 300 divided by b squared. We will use this for substitution later. Adding the surface area of the base with the surface area of the sides gives me the total surface area of the box. I multiply the cost of the base material, $12 per square meter, by the surface area of the base, and I multiply the cost of the side material, $7 per square meter, by the surface area of the sides. By adding these two quantities together, I now have an equation of the cost in terms of b and h. However, I can substitute the value of h with 300 meters squares as mentioned before. With this substitution, I can simplify and get the cost of the box in terms of the length of just the base.
Next, I need to know the minimum cost of the bin. So, I need to go to my calculator, navigate to the y equals button, and type my equation into y1. Then, I need to set my window in order to view my graph properly. I need to press the window button, then set my x minimum to -10 and my x maximum to 50. Next, I need to set my y minimum to -5 and my y maximum to 20,000. After this, I press the graph button. Now, since I'm looking for the minimum cost, I need to press the second button and then the trace button. Now, I need to select the minimum option. Now the graph reads left bound, so I need to use my arrows to move the marker to the left of the minimum point. Then after this, press the enter button. Now the graph reads right bound, so I need to use my arrows again to move the marker to the right of the minimum point. Then after this, press enter. Now the graph reads guess, and I press enter one more time. Now it gives me the coordinates 7.0473 and 1787.9191. The y value is the minimum cost. So, the minimum cost is $1,787.92. Finally, I need to know the dimensions of a box whose cost is $4,000 if the length of a side of the base is greater than 10 meters. So, I need my calculator again for this one. This time, I need to press the y equals button again, leave my initial equation in y1, and type in 4,000 into y2. Now I press graph, and then press the second button, and then the trace button. Now I select intersect, and press the enter button every time after the graph reads first curve, second curve, and guess. After this, the graph shows me the coordinates 17.099612 and 4,000.
This x value tells me that for the cost to be $4,000 and the length of the base to be greater than 10 meters, the length of the base has to be 17.1 meters. Since 17.1 meters is the length of the base, we can plug that value in for x for our volume equation. By solving for h, we see that the height of the box has to be 1.02 meters in order for the box to have the correct volume. This means that the dimensions of the box, where cost equals $4,000 and length of the base is greater than 10 meters, is 17.1 meters by 17.1 meters by 1.02 meters.